Welcome to my channel Code with Fernando. Today we are going to continue with Module 3, Reactive Stream Specification. I just want to mention that this is going to be more like a theory video because it's really important, it's necessary, really important to understand what I'm talking about, what it means Reactive Streams, because next video we are going to be working with Project Reactor, and Project Reactor is based on this Reactive Stream specification. So that's the main reason why this video is going to be like a theory. And I just want to mention also the I have already created an article. Okay, in this article you will have a very deeply understanding about what I'm talking about. Also, if you want, you can check a complete code demonstration. This is going to be the implementation. Okay, let's continue with introduction to Reactive Streams. Reactive Streams is a standard for handling asynchronous data streams with non-blocking back pressure. Okay, we already know what back pressure is. So it defines a minimal set of interfaces and rules that govern how data flows between producer, the one who emits the data, the publisher, and consumers, and in this case the subscribers. So we have two actors in here, the publisher and the subscriber. Why it matters? Enables efficient, resilient, and predictable data flow, even under heavy load. It helps avoid memory overflows, drop messages, and slowdowns. Okay, like I told you before, this is the foundation for modern reactive libraries like Project Reactor and Avex Java. In these videos, we are going to go for Project Reactor. Okay, so in this module, you will learn about the core interfaces of Reactive Streams. This is really important. The signal life cycle we have on subscribe, on next, on complete, or on error. Then we have the essential rules and behaviors each component must follow. Okay, understand the concurrent flow. So we need to understand what is flow. Okay, flow is a Java 9 specification that defines the session building blocks for reactive programming, asynchronous, non-blocking, and demand-driven communication between components. So it is a part of Java's adoption to this Reactive Stream specification, allowing different reactive systems and libraries. So if we go to the doc of Flow, technically, Flow is a finite class. It's a finite class, so it means that you can extend that class, right? But it's more like a container because in this finite class you will find these nested interfaces, static interfaces, processor, publisher, subscribe, and subscription. Okay, so let's continue. What are those interfaces? Okay, publisher, remember, is the one who emits the data, the one who produces the data. Okay, but only when requested. The subscriber is the one who consumes the data. The one who consumes the data requests how much it can handle. Then we have the subscription. Let's see the subscription like a bridge. Okay, it's like the link, the contract between the publisher and the subscriber. Is the one who connects these two, publisher and subscriber. So the subscription is really important because it enables request and cancel. Okay, and finally we have the processor. The processor acts as a subscriber. The processor as a subscriber and a publisher at the same time. Okay, so the processor have the methods of those two. How it all comes together. Flow makes sure that data flows on demand. It means the consumer controls the pace. So the consumer, okay, is the one who controls the pace. The system remains responsive under load. This is thanks to back pressure. Resources are managed cleanly. No memory leaks from unbounded queue. Errors don't go unnoticed. They propagate clearly through the stream. So what is flow exactly? Okay, flow is a finite class. It's a finite class that contains nested static interfaces. These interfaces, okay, publisher, subscriber, subscription, and processor. These interfaces define the Reactive Stream contract, but flow itself is just a namespace. It's a container. Okay, so let's see core interfaces and the responsibilities. Reactive Streams defines four core interfaces. These interfaces are publisher, subscriber, subscription, and processor. Okay, let's see how they all work together. First, we have the publisher. Publisher, the data producer. Okay, the publisher is the one who produces the data, is the source of data. It doesn't push data right away. Instead, it waits for a subscriber and only sends data when requested. Some key points to remember. It has only one method. This method is called the subscribe method. It takes a subscriber. Okay. Through that method, it calls the subscriber lifecycle methods. Okay. These lifecycle methods are unsubscribe, unnext, unerror, and complete. Okay. Let's see an analogy. Let's imagine the publisher is like a waiter. Okay, like a waiter, it only serves food when the customer asks for it. So there's a customer, there's a waiter. The customer asks for food. The waiter is responsible to produce the food. Okay. Then we have a subscriber. Okay, the subscriber, the data consumer. Subscriber is the one who receives data from the publisher and reacts to each event in a stream life cycle. So these methods are unsubscribe, unnext, unerror, uncomplete. Unsubscribe when subscribe. Then we have unnext when data is received. Unerror, on failure, and incomplete when stream ends. Responsibilities. Um, Subscriber responsible to control the data flow using subscription requests. Okay, can cancel the stream anytime. React to data completion or errors. Analogy. We are talking about a restaurant. So analogy is like a customer at a restaurant. So the subscriber is like customer. It decides how much food to get and when to stop eating. So we have the publisher is a waiter of the restaurant, okay, a waiter, and we have the subscriber. The subscriber is like the customer, the one who decides how much food to get and when to stop eating. Then we have the subscription. Subscription is the flow control link. Also, another way to see the subscription is like bridge, the bridge between a publisher and subscriber. Okay, the subscription is a contract that connects publisher and subscriber. It gives the subscriber control over the data flow. A subscription has two main methods: request and cancel. Request asks for n items, okay, and cancel stop receiving more data. Why is it important? What it matters? Because subscription is the one who enables back pressure. Subscriber control the pace, but not the publisher. Okay, prevents overloading slow consumer. It supports asynchronous, non-blocking, and resilient systems. Analogy. Let's continue with a restaurant analogy. The subscription is like an order from a restaurant. Okay, the customer is a subscriber. Tells the waiter, the publisher, how many dishes to bring and can cancel at any time. Okay, the subscription is like an order from a restaurant. Finally, we have the processor. The processor is the data transformer. Okay, that the processor plays a dual role in Reactive Streams. It it acts as a subscriber and a publisher at the same time. Okay, key points: a processor is both a subscriber and a publisher. It connects upstream and downstream, processing and transforming the data along the way. So these processors have already inherited the methods from those two, the subscriber and the processor. Analogy, like a kitchen prep station. Okay, it receives raw ingredients, process the food, then passes to the prepared dishes. Let's continue with signal lifecycle in Reactive Streams. A signal is a message sent between the publisher and the subscriber. These signals are part of a fixed order called the signal lifecycle. Okay, it controls how data moves through the reactive stream. So what each signal represents? We have four steps. The first one is unsubscribe. Okay, this is always going to be the first signal. It establishes the subscription contract. Then we have onNext. OnNext can be called 0 or more times. Okay, this one is the responsible to deliver a single data item per invocation. Delivers a single data item per invocation. Then we have onComplete. This is called exactly once if the publisher completes successfully. only if the publisher completes successfully. And then we have on error, call once only if an error occurs. If there is an error with the application, this signal will be called on error. Okay, I have a class in here called signal lifecycle example. Inside we have our main method, okay? So let's create a flux of string, type string. Okay, let's call this flux. Then let's generate just some names. Maria, Claudia, and what about Ghost? Okay, so the first one is do unsubscribe. Okay, unsubscribe. Okay, so we are going to see this first. This is the first signal. Don't forget that. Ooh, okay. Okay, then what do we have on next? This is the next signal. This signal will be called, can be called 0 or n times. Okay, I'm gonna be called item. We are going to print this one on next, and we are going to print item. So finally, not finally, we have do incomplete only if it's successful. Okay, do incomplete. And then if in case there is an error with our application, this signal will be called do on error. Okay, and let's call this error, and let's print this do on error, and we want to see the message. Yeah, get message. Okay, then we need to subscribe. Nothing happens in reactive programming unless you subscribe. So we have already printing this. We don't need to print again. And after that, we are not going to print the error. Okay, then what do we have? And finally, we call completed. Okay, so what's going to be the flow? First one, we are going to see this unsubscribe, do unsubscribe. This is going to be printed on the console on do unsubscribe. After that, we are going to see do on next and the name. Do on next, next name. Okay, in the last one. After that, we are going to see the do complete signal. Okay, because we don't have any error in this application, so we are not going to see this do error. And finally, we are going to see completed. Okay, let's print this. Great. Do on subscribe, this one, then do on next the name, do on next the next name, and finally ghost. What do we have after that? Do on complete. Okay, this signal, because we don't have any error, that's why we don't see this do on error signal. Finally, we have completed. Summary. Here is what we have learned. Reactive Streams defines a simple but powerful system using four main interfaces. These interfaces are publisher, subscriber, subscription, and processor. Okay, these components follow a clear signal flow. The first one, on subscribe, on next, and finally either on complete or on error. Okay, then subscription request. Okay, method is how the subscriber controls the flow. This is called back pressure. Okay, because and then if you break the contract rules, it can cause errors or unexpected behavior in your stream. Learning this basic is very important before moving on to advanced tools like Project Reactor or RX Java. Okay, we are going to be working with Project Reactor in this series of videos. Okay, thank you so much. Please like and share and subscribe. Bye.